Hello, my name is Markus and I will show you the new developments at the user interface and the GRAL version 18.01. This is an example with multiple source groups. We switch to the Sources tab. I will compute all available source groups within our model domain. So I select them and move them to the Selected Source Groups list box here. In the previous version, I had to double-click each source group and set an emission modulation. In the new version, this is mandatory. By default, a continuous emission modulation is set by the user interface. If an emission modulation has been set in an earlier project stage, these emission rates are still set, like here for the source group stack. On the right side, we will see emission modulation preview. I just have to select source groups to update the preview window. At the Meteorology tab, we will open the MET file and at the Windrows window we will see two new buttons. Here it's possible to set font type and font size, and here it's possible to lock the automatic scale mode. So if I set a scale and hit this button, the automatic scale is blocked. This is a nice feature if you like to compare different methodological stations. At the GIS window, we will see a new button here at the Georeference section or in the menu File, Georeference Map, Move and Zoom Base Maps. This option allows a fine-tuning of already georeferenced maps. That might be a nice feature if the georeferencing isn't perfect. For example, if a map is not perfect northwarded. I load a second map that's an already georeferenced sketch drawing. And I set the opacity a little lower because I'd like to set pure white map areas to transparent. And if I zoom in, I see that the georeferencing isn't perfect. Now it's possible to use this button. I push the button and use the cursor keys to shift the map and the plus or minus keys to zoom the map. At the end, I hit the button again, or if I like to cancel the procedure, I hit the escape button. Well, now the position of the map is stored. The world file is not changed in this case. Then we see a new option here in the three-dimensional view. It's possible to select either the GRAMM or the GRAL topography. We will show the GRAL topography now, and what we see is an almost flat terrain with some receptor points. That's our GRAL topography for this example. And I keep this window. At the Tools menu, there are new options to modify the terrain. It's possible to increase or decrease the height for an absolute or a relative high, or to smooth the topography using a 5-point low-pass filter. I try to increase parts of the topography for a relative high of 10 meters, so I set 10. I don't use an absolute high here, that's a relative value. I set the pen size, that means how many cells are affected with my pen. 5 times 5 means 5 times 5 cells. If I use, for example, 5 meter per cell, I've got an area of 25 times 25 square meters. And it's possible to set the maximum and minimum height that should not be exceeded. If I hit OK, it's possible to paint like a pen, and all cells that are painted are increased by a height of 5 meters. Sorry, 10 meters in that case. If I do that multiple times, it's not changed. It's still 10 meters as long as I keep the mouse button pressed. And I build a little rock here. So the height is indicated in the upper right corner or in the three-dimensional view. Here it's possible to see that new terrain compared to the original topography. Here we see the difference. Now let's take a look to the new optional GRAL computation core for the latest .NET Core 2.0 framework. That framework is not installed by default. You can download the framework on the Microsoft homepage. These cores for GRAL and GRAMM are a little bit faster at Windows, but especially for GRAL, much faster on Linux than the still delivered mono computation cores. At Windows, you have to select the batch file to start the .NET Core version. I'll try that. I have to open that folder and select the batch file. The batch file will execute the command .NET GRAL 2018.dll. I start it, and the .NET Core version starts to work. It is recommended to wait a little bit, because if sources with null particles are detected, the GRAL core will ask you what to do. And we see such an example here. We see 2 line segments with null particles and 1238 area source segments or partitions with null particles. So I would say we take the escape key and we are looking to the GRAL settings tab. Well, we see we use just 5 particles per second. That means 18,000 particles per dispersion situation. These particles are allocated to the sources or source segments by their emission rate. At line sources, we might have very short line segments. A short segment has a very low emission rate, and therefore this segment will get no particle. If there are only a few such segments, like in our example, that's absolutely not a problem, and we could continue our computation. At the area source, we saw a lot of segments without particles. Area sources are divided by a user-defined raster. If this raster is too low, the area source parts are very small and the emission rates are low. We see that division at the source dialog. The raster size is 2 meters and we have a low emission rate. So it's recommended to increase this raster size and to increase the number of particles, let's say 25. And to restart the computation, we have to set the emissions again and to write new emission files, because we changed the raster size of the area sources, and we try to restart the computation, and the computation is running. Finally, we can take a look to the new log file from the computation core. Here we see the log file, computation core. I open the file, and here we see our first try. We see the warning message that there are null particles, 2 line segments, and more than 1,000 area source partitions. And this is the documentation of the last run. We see the emission rates of each used source groups for point sources, line sources, and area sources, the number of particles, the dispersion time, and some informations about the concentration grid, the number of cells in X and Y direction, and so on. I hope you enjoyed this tutorial. Bye.